Okay, so welcome to today's video tutorial. I thought I had talked about this in a video prior, but I guess I didn't. So today we're going to talk about some more security issues, and we're going to go over, some differences that exist from a security point of view from something like WASM versus unikernels. Now, before I kind of really get into this, I just want to point out that uh, we can actually run lots of WASM runtimes today. So if you go to the package hub, you can see WASMer, you can see this WASMe, you can see WASM Edge. Um, I thought we had WASM time. I'm going to show it later on, but unikernels and these WASM runtimes are not actually mutually exclusive. You can actually run WASM inside of a unikernel if you really wanted to. What I wanted to show you today was some of the security issues that crop up in WASM, and in fact, they crop up in other unikernel implementations that are out there too. So be very careful. Like you want to choose these runtimes carefully. Otherwise, you can get yourself into a lot of trouble. So let's go ahead and get into it. Um, I've kind of harped on this in the past, and some people don't really understand some of the security issues that are at play here. So I'm just going to show you them, right? Let's look at this. Let's look at this one first. This hi.c. I'm going to blow this up so everybody can see. I know people have complained about that in the past. So this is pretty basic, right? Basically you look at this and this supposedly says hello world. You can see there's this owned being inserted here, but this is not actually totally legal to do because you're basically overwriting read-only memory here. And so if we want to run this on Linux, we run it and we get a seg fault. Why? Because the this elf file right here, this this uh, this string, this world, is actually inside of a section inside the elf file that's marked as read-only memory. That is, we don't want anybody to change it at runtime. So it's really problematic when you allow people to change it, because what else goes into read-only memory? Well, you have code. So like when I compile this code, um, bits of that code wind up in read-only memory. But if that doesn't exist, then an attacker can just choose to overwrite it with whatever the hell they want to. And that's what we can do here. So we can pull out WASMer and we can say hi.wasm and says hello owned, right? So this should not happen. This is a huge security risk. We can also use WASM time just to show you that it's doing the exact same thing. It doesn't matter which WASM runtime you're using. I'm showing both here just to prove this out. This is just an inherently broken thing that WASM has today. And frankly, I don't know if they're ever actually going to fix this, because they would need to redo how memory is actually laid out. And that kind of dovetails into getting all the browsers on board and making them decide what they want to do. And so it's kind of an issue. All right, so lack of read-only memory. That's a big security violation. And by the way, just to show you here, it'll seg fault under Nanos as well, which is what you would expect. You just don't want this to happen. So next up, we have this guy. So fump.c. All right. So in this one, this is a classic buffer overflow. It's kind of funny because if you go to the WASM website, they talk about the fact that this supposedly doesn't exist, even though I'm going to show you that it totally exists. Basically, you have this vulnerable function. You pass it in your string, and you have this admin, right? And essentially, it should be returning a certain thing, but it doesn't, right? So if we run this here, we say Linux says, hey, there's stack smashing detected, and it terminates it. Now notice the 0 because that's what it was set to, right? Now let's run it under WASM time. Oh, shit. And if you notice, A, we're admin, which we shouldn't be, but B, that number has changed. So that's bad news bears, right? So this is another thing where we're running into trouble because certain security benefits that exist on Linux don't exist in WASM. Now let's check out this nil.c. So this one is pretty interesting. Basically, what's going on here is there's this concept that you really don't want to write to nil. That is 0 in memory. And the reason why is because a lot of these variables initialize themselves at that. And so we have this pointer Bob, and we set it to 0, and then we set Bob to 42. So what happens here is that the value of Bob's 42, and then we initialize a new guy down here, Tom, and Tom gets set to 42 as well. Now, of course, this doesn't work on Linux, so let's just run this real quick. Here you can see again we segfault because this is just bad. We don't want this behavior. Now let's run it under WASM again. Do nil.wasm, and as you can see, value 42, 42. Hold up. Let's go back to our code. Why are both of these 42? Tom was never set to 42. This is the issue. And the issue is like if you can just set arbitrary variables to whatever you want as an attacker because you've overridden nil, then it's game over. Think about how many different checks happen for various integers. Maybe an admin user is stored as the variable 0 in a database, and when you read that out, or it's stored as 1 or whatever. Think about different numbers that get set in crypto routines. There's so many different ways to screw over a program when you can do this. And that's why it's not allowed in Linux. It's not allowed in Nanos. It's a major security issue, but WASM allows it. So I showed you 3 different attack techniques. There's quite a few more. And I would encourage you all when you're exploring WASM to keep in mind that these security vulnerabilities exist, and I don't think they're going to be fixed anytime soon. Again, not trying to be so hard on WASM here. I'm just saying that they exist. They're not going to be fixed anytime soon. So, be careful what you're doing. Until next time, bye.